Hello. Right now, we're going to do the level 2 where we're using law of sines to solve for missing sides and angles. Now, first, I'd like you to think about this. How can we solve for a missing side in this triangle? We used to be able to use sine, cosine, and tangent if we have right triangles, but this isn't a right triangle, so we need a new property. So what we need is this thing called the law of sines. And what it says is for any acute angle with angles measured A, B, and C and sides little a, little b, and little c, where little a is opposite of big A, little b is opposite of big A, big B, and so on, there's this equation. Sine of A over A is equal to the sine of B over little b equals the sine of C over little c. Now this is a big equation that we need to understand. Uh, it really helps us out when our triangle is not a right triangle. Let's go on to our first example. So let's solve for a missing side here, or missing sides and angles. Now here we have our triangle. It is not a right triangle, and uh, let's call this A, B, and C. That means this side is going to be little a, little b, and little c, because the lowercase is always opposite from the uppercase. Now, if I want to set up my law of sines, you look for an angle and the side opposite. We have a 70 and the side opposite is 17. So I can write the sine of 70 degrees over 17 is going to equal angle C. So the sine of angle C over the side opposite of that, which is 12. Now, this sets up a situation like we used in level 1. To solve for sine of 70, we type in sine of 70, and we have 0.9397 if we round over 17 is equal to the sine of C over 12. Now we cross multiply. If we multiply this times 12, I get 11.2763 is equal to 17 times the sine of C. So we'll have to divide by 17 to get 0.6633 is equal to the sine of our angle. Now to find this angle, C, this angle right here, I have to take the inverse sine of 0.6633. And if I take the inverse sine of that, I have this angle C is 41.55. Or if I round 41.6 degrees is that angle. All right, let's try another one using the law of sines. Here, we have a situation where we have two angles on one side. So if I want to find my side over here, AC, you look for an angle and a side opposite, and we can write our law of sines proportion. Sine of 65 over the opposite side, which is 80. Set that equal to, if I want to find AC, the angle opposite of that is 85. So I'll say the sine of 85 over x. Now, I take the sine of 65 and the sine of 85, and I have sine of 65 is 0.9063. Sine of 85 is 0.9962. And now I just cross multiply and divide. I'm going to multiply that by 80 to get 79.6956. Multiply those, 0.9063x. Divide that by 0.9063. And my value for x is 87.9. And that's this side over here. So we can use the law of sines. It works really good when the triangle is not a right triangle. Let's try another one. Here we have two angles again, and one side. Now, one problem here is we have a side, but not the angle opposite. So what we have to do is add these two sides, 25 plus 115, and we have 140. If all three angles have to add up to 180, 180 minus 140 leaves us with 40 degrees left over. All right, so now we can set up our law of sines. Sine of 40 over at its opposite side, which is 43. Now if we want to find AC, that's this one down here, so we'll do 115 and AC. So that would be the sine of 115 over its opposite side, we can just call it x. Now, we have to find the sine of 40 and the sine of 115. So we type in our calculator, sine of 40, sine of 115. Sine of 40 is 0.6428. Sine of 115 is 0.9063. Now when I cross multiply and divide, this would be 38.9712. Now I divide that by 0.6428, and I have an x value of 60.6. Excuse me. So if this is 43, that makes sense that that would be 60.6. All right, hopefully you're understanding the gist of how to do these problems. And I have many more examples here, but how about you try some on your own and see how it goes?